Have you ever looked at Python code where a class inherits from like 2 or 3 different parents and just thought, how on earth does that work? Well, today we're going to solve that exact puzzle. We're diving deep into Python's inheritance system, and I promise by the end of this, you'll get how it all clicks together.
All right, to get started, let's forget about code for just a second. Just picture a child. They get traits from both parents, right? Maybe they've got their mom's eyes, but their dad's height. This kind of blending is totally normal in real life, and it turns out it's a thing in programming too. And what we're talking about here actually has a name in the programming world: multiple inheritance. It's really just a fancy way of saying that one class, our child class, can inherit from more than one parent. We're basically taking that real-world idea and plugging it straight into our code.
Okay, so let's see how this actually works in practice. In this first part, we're going to take our little analogy, one child, 2 parents, and turn it into real live Python code. In Python, the way you write this is incredibly simple. You just list out the parent classes right there in the parentheses, separated by a comma. I mean, looking at it, it seems almost too easy, doesn't it?
But here's where things get interesting. This is where the puzzle really begins. Let's imagine both the father and mother classes have a method, and it's called the exact same thing: skill. The catch? They do totally different things. The father's skill is driving, and the mother's skill is cooking. And that right there, that's the heart of the puzzle we need to solve. What happens when there's an overlap like this? How does Python figure out which parent's skill the child should actually use? So the big question is, when we create an instance of our child class and we call that skill method, what's going to happen? Is the child going to start driving like their father, or are they going to start cooking like their mother? This isn't a trick question. It's a real problem that Python has to figure out every single time.
Well, the good news is Python isn't just flipping a coin or guessing here. Nope. There's an official rule book, a clear, predictable set of rules that it follows to solve this exact puzzle.
And that rulebook is called the MRO, which stands for Method Resolution Order. The best way to think about it is as a search path. It is the precise step-by-step order that Python follows when it's looking for a method in a family tree of classes. So how does this search path actually work? Well, it's pretty logical, really. First, Python looks in the child class itself. If it doesn't find the method there, it moves on to the parents. And here's the absolute key to solving our puzzle. It checks them in the order you listed them, from left to right. Only then does it continue up the chain. And check this out. This is where you see that left to right rule in action, plain as day. If we define our class as child, father, mother, Python looks at father first, finds skill, and boom, it prints driving. But if we just swap them and write child, mother, father, it checks mother first and prints cooking. The order you list them in literally changes what your program does. And the best part is, this isn't some kind of secret black magic happening under the hood. Python is totally open about it. You can just call the .MRO method on any class, and it will literally print out the exact list, the exact order that it's going to follow. You can see the rulebook for yourself anytime you want. All right, you've got the basics down, so let's crank up the difficulty, shall we? It's time to talk about the classic boss battle of multiple inheritance, the diamond dilemma. This is where things can get super confusing, but don't worry, the MRO keeps it all straightened out. So here's the setup. Imagine you've got this one grandparent class at the very top. Let's call it A. Then you have 2 other classes, B and C, and they both inherit from A. And to top it all off, you have a final class, D, that inherits from both B and C. You see how that forms a diamond shape? The big question here is, how does D find a method from A without getting confused? Now, you might think this is where it all falls apart, but Python has this brilliant algorithm called C3 linearization to handle it. And let me be clear, you do not need to know the math behind it. Just know that this thing is a genius at creating one single, consistent, logical order, the MRO, that solves the diamond problem perfectly every time. This is also where the super function really shines. In these tricky situations, super is way smarter than just calling the parent. It actually follows that MRO path we've been talking about. This makes sure every class in the chain gets called in the right order, and, just as importantly, that it only gets called once. Okay, so we've dug into the how it all works. Now let's talk about the should we a bit. Because like any really powerful tool, multiple inheritance can be absolutely amazing, but man, it can also be dangerous if you're not careful. So when should you maybe put this tool back in the toolbox?
Well, if you find yourself struggling to explain how your classes are related, that's a huge red flag. If the parent classes have nothing to do with each other, like you're trying to inherit from a car and a cookie, you're probably going down the wrong path. And a lot of the time, if you just want to reuse a bit of code, there's a much safer pattern called composition.
Today, it's not all doom and gloom. There are definitely times when multiple inheritance is the perfect tool for the job. It's awesome for something called mix-ins. Think of them as little plug-and-play classes that add a specific feature, like logging. As long as the roles are super clear, or if you're using a framework like Django that's designed for it, it can be really powerful.
So really, it all boils down to this one simple piece of advice you'll hear from pretty much any seasoned developer. Multiple inheritance is powerful, for sure, but it can be dangerous. You've just got to use it carefully and with a very clear purpose in mind.
So there you have it. The puzzle is solved. We've pulled back the curtain on the method resolution order. The question isn't what will Python do anymore? The real question is for you. Now that you know the rules of the game, how are you going to use this power to write code that isn't just more capable, but also clearer for everyone who comes after you?